So in the memory hierarchy, first the type of the memory is a CPU registers only. Next level of the memory is a cache memory. Next one is a primary memory. Next one is a secondary memory. Example of the primary memory:
DDR.
Yeah, RAM, DROM or ROM. General RAM, ROM. Yeah, primary memory example. Secondary example: hard disk, storage memory, your CD-ROM, pen drive, like that, SD card. So CPU registers are very small memory only, but highest speed of operation. Highest speed of operation, because CPU registers are within the processor. So already your people know also move A comma B instruction. So very faster. Move A comma B very faster, because the 4 pieces now. So the meaning of move A comma B, the data transfer from within the processor. CPU register to one register to another register now. So CPU registers are very fastest memory, but the problem is a small amount of memory only. So general CPU registers are what? So the very small registers, no? Okay, maybe within the 10 to 12 registers one, very small amount of memory. Even not 1 kilobyte also, very small amount of memory only. Some bytes, depending on the architecture, small number of bytes, 100 bytes like that, limited one now. It's very small size only. The size in the form of bytes. So next level is a cache memory. Cache memory size is also available, megabyte available in the market nowadays. 4 mega cache, okay, 8 mega cache, like that only. But cache memories are available level 1 cache, level 2 cache, like that. Some levels are there on level. Okay, level 1 cache memory 4 MB, level 2 8 MB, like that actually. So levels now. So what happened? The level 1 first processor check the code in the level 1. Level 1 is not available, check the level 2, like that. So multiple the memories are, we can interface one by one. Okay. So cache available very smaller only. If you want to need a highest cache memory, very costlier. No, we can't affordable, very costlier. That's why we can go to the small size only, cache memory. Cache memory also speed of operation, yeah, very perform operation, but compared to register, slowest only. Compared to primary memory, faster. Cache memory, the speed is in the form of GHz speed only available in the market. Primary memory speed available megahertz speed only. Your size megabyte only, but your size nowadays size available gigabyte only. Yeah, 4 GB RAM, 8 GB RAM, okay, 16 GB RAM, 32 GB RAM. So GB available on RAM, gigabyte. Size is a more compared to the cache memory, but slowest operation, speed megahertz only. Your speed gigahertz only. The meaning of gigahertz process speed only. Process speed of nowadays gigahertz speed, microprocessor speed. Microprocessor speed can match the cache memory. Secondary memory size very bigger size nowadays, terabyte size. Okay, size more okay compared to that one, but your slowest operation, very slowest performance only. The speed is in the form of the kilohertz speed only. Okay, okay, the very slowest speed only, slowest speed operation compared to all other type of memory. Secondary is the slowest operation, very slow operation. Microprocessor speed gigahertz only, kilohertz speed only. The synchronization is a very difficult. Okay, so that's why we need some intermediate synchronization point of view. Okay, so these are the called a hierarchy. Okay, memory hierarchies now. So total these are the type of the memories now. So now if you come to top to bottom, top to bottom, top to bottom, you can down, okay, towards. Whenever you can travel top to bottom side, speed of operation improve or decrease? Speed.
Decreases.
Okay, your top to bottom speed should be decreased only. Size increasing, size increasing one now. Correct now. The last one terabyte, starting one only bytes one now. Size is increasing one now. Speed, size, cost. We are coming to this area, cost.
Decreases.
Cost is a decreasing only. Correct now?
Yes.
Cost decreasing on cost. I think 1 terabyte is a 4,000 or 3,000 rupees in the market. You know, 4 GB RAM is the same price only, 4,000 rupees. Decreasing now. So what happened? Overall, you are responsible to what? If you are going to design a system, you can moderate everything now. moderate. Okay, now the how much size required, that only size you can take it now. Unnecessarily don't go more size, cost is a more incremental now. Your RAM size 8 GB sufficient, but unnecessarily go to 32 GB because price more on now. Okay, yeah, what is the requirement of the RAM, that you can check it now. Okay, like that, now the storage memory also. Okay, whatever we need. Okay, cache memory, whatever your requirement is there, according to that one, you can design the system. Computer system architecture diagram, see like that. Okay, first processor. Here you have CPU register, perfect. Okay, next level of the memory is a cache memory, L1 cache like that, L2 cache like that. Cache memory, L1. Next one L2. In case L2 is there, L2. Otherwise, so next memory is a primary memory. Primary is a RAM, a DRAM something. Primary memory. Next one. So last memory is a we are communicated to. That end is a memory is a secondary memory. Is called hard disk. Secondary memory. Hard disk. So the microprocessor responsibility to load the program. Okay. So microprocessor job is what? Execute the code, read the code in the memory. But microprocessor, how to load the program? Nothing but first program counter, instruction pointer. It can hold the address of the memory. So which program to execute, you can hold the address of the memory. But operating system point of view, the memory management point of view, cache memory compulsory. Low level microcontroller doesn't require, but here cache important, especially performance point of view. Cache memory very important here. Cache more your system performance really good, because cache memory speed gigahertz now. Process speed and this speed both are equal. Performance really very good now. RAM speed megahertz only, slowest operation. So processor should compromise something now to communicate the RAM. Processor to communicate the hard disk very slow now. Very slow. That like that. No, so you want design. Okay. The program counter first try to find out the program in the cache memory only. Program counter to first go to the level 1 cache, find out the program. In the very small memory. So in case program is available, okay, load the program. Very quickly execute also. The microprocessor really enjoy. Okay, because your program is available very faster. In case your program is not available, the memory address not available, because small amount of memory here not available, what happens? You can look this one more level, L2, second level of the cache memory, second level looking also. In the second level also, the address is not available. In case, because small memory now, okay, 4 MB or 16 MB, small amount of memory now, so very small. Here program is not available, here program is not available. What happened? The next one, RAM only. So yeah, levels now. So first to microprocessor responsibility, first to check the level 1. The level 1 program is available. No, what are the program you expected microprocessor, program counter, address available, load the program now. Otherwise, level 2. Otherwise, finally, DRAM also. DRAM. But DRAM is a slow operation, but finally DRAM can load the memory now. In case DRAM is also not available, you know also, every day you face the problem. What a problem?
Segmentation fault.
Application programming. Application programmer face this error, segmentation fault. Okay. Technical one is called a page fault error. Technical, behind the operating system, behind the internal mechanism is called page fault error now. Page fault error now. The meaning same only. Now segmentation. So I told you, segmentation area in the memory, microprocessor to communicate the memory. Anywhere L1, L2, final RAM also. Anywhere it is unable to find out. Okay. Finally, segmentation fault. Example pointer, null pointer. Null pointer you can't find out L1 also, L2 also, here also. It's failed. Everyone, okay, fail. Segmentation application pointer. But internally behind what happened? Page fault. So memory, the segmentation. Every segmentation contain the pages now. Internal pages are there. Okay, data segmenter contain the 10 pages, 15 pages, 20 pages. Segment the area. Okay, how many number of pages? That is depends on the program size now. The programmer decide now. Program size. Okay, depending on program size, number of pages in the segment. Data segmenter. My program data segment contain 10 pages only. Your program maybe 20 pages or 30 pages only. The size, program size decided now. Okay, So the page not available now, page fault error coming. Whenever the operating system point of view, operating system, okay, memory management is a one of the operating system service only. Operating system point of view, whenever microprocessor unable to find out the memory in the cache memory, it can operating system internally raise a miss option, miss. Operating system internally raise a miss. The meaning of miss indication go to next level only. Okay, all the levels miss coming only, segmentation fault only. In case memory is available, raise a hit only, hit. So operating system, the rising hit or miss rising depends on the memory address available or not available. For example, more number of misses are there only, more misses, miss, most of the time missing only, address not available, final RAM available only. Again, address not available, most of the time misses are more number of misses only. What happened? System performance
Decreases.
decreasing only. Yeah, more number of hits are there, system performance, tell me.
Increases.
Increased.
Okay, system performance depends on the number of hits only. So when the hits are more, then happen like that. But operating system responsibility, operating system, that is the operating system memory management responsibility, try to implement more number of hits only. How to implement? That is the concept actually. How kernel how to create a more number of hits only. How the things nothing but, okay. So kernel what happen actually? So more number of hits are happen. So when most of the program available here only. How is possible? For example, we have some program is there, okay, some lines program is there, 100 lines code is there only. We have 100 lines code. In 100 lines program, we can identify out of 100 lines code which lines program running more frequently. We can identify first. For example, in the for loop is there, for loop run 100 times only. In the for loop contain internally 10 statements only. So for loop execute the 10 statement 100 times only. So now can identify out of 100 lines, this program run the more number of times only. Okay, so what happen? For loop 100 times run only, microprocessor communicate the for loop, load the instruction, execute 10 statement, again communicate again. So microprocessor to communicate the 100 times, no, but the 100 iteration, okay, 100 iteration the program in case the RAM is there, here is there, microprocessor to communicate 100 times, no, your performance not good.
Yes, sir.
This for loop we can copy the L1 cache, the for loop code you can copy the L1 cache, performance improve or not?
Yes, sir. Increase.
That is the concept actually. How it works nothing but this called a more frequently required information. Frequently required information you want to identify on. Frequently required information. Kernel responsibility, the memory management is a responsibility to identify the frequent required information in your program. That program you can copy to the cache memory. That program copy the cache memory only. Then your job is a performance should be improved now.
Yes,
So
sir.
that's why cache memory plays very important role now your system. How to communicate the hard disk to here? Okay, for example, in your hard disk run dot class a dot out. Your hard your okay run okay. A dot out is some folder. Okay, go to the folder can execute now. What happened? This a dot out moving from your hard disk to here on now. So the program moving into here to here, the memory might find out, okay, everything moving here, but here cannot directly moving here. There is some kind of the interface required actually, because there is some peripheral. They are also some peripheral. Both are the peripherals only, but you want transfer the data. Okay, now the here to here data will transfer now. Okay, the a dot out contain the program you want transfer to here only, but transfer data generally happen to processor only. Okay, so processor have the more burden. That's why we are one more to the co-processor introducing only, but we call it DMA processor, direct memory access processor. DMA co-processor, we call it co-processor, IO processor like that, IO processor, DMA. So with help of DMA, we can transfer the data here on DMA, direct memory access. DMA but here the meaning direct memory access, the hardware device, the peripheral, the chipset, programmable IC, programmable integrated circuit, the IC now. This responsibility transfer the data from hard disk to the RAM. because hard disk is slower communication. The RAM is a faster one. So synchronization through buses actually. Data transfer now. Okay, happen now. DMA, direct memory access. DMA contain the buffers only. DMA channels. DMA also contain channels on channel. Channel 1 is a one buffer. Channel 2 one buffer only. Channel 1 dedicated for one area in the hard disk. Channel 2 one more area like that. DMA is very, very important in our embedded system actually. Okay? The dedicated channels are creating.
DMA would be part of the SoC or is it a different peripheral?
Yeah, the microcontroller point of view SoC one, correct. No, the desktop point of view or general purpose computer, microprocessor different, DMA different. Both are independent chipsets on ICs.
Okay. But if in case of SoC, the DMA would be there already.
Yeah.
At the SoC.
SoC now.
Okay.
So any high-end microcontroller contain the DMA now. Almost every microcontroller can find out.
Okay. How about the cache memory, sir? RAM, I know that it will be separate, but cache memory will be available already.
Now, for example, that depends on. For example, I buy the processor i3 processor in the market, i3. So i3 processor, the architecture mentioned the manually. i3, how much cache is provided? That cache is on chip actually, not external. On chip now. On chip. On chip now. On chip is coming, not external. External can't available. DRAM is we can plug on the remove and the external. Cache is on chip actually. So our microprocessor on chip is available. So we can check it out. So cache memory. If you run the command like a task manager, okay, the Windows, you can check it immediately. Okay. So what is the cache memory? What is your system performance? So now my system is there. So maybe you are able to see now.
Yeah, I could see, sir.
Yeah, you can see now. So my system you are able to see now. Check it now. So there are 3 cache memories are there on my system. 3. So L1 cache, L2, L3. Okay, 384 kilo megabyte is there. L2, L3. So cache is on chip only. Processor speed 3.5 GHz on chip only.
But as we change RAM and also we don't have that option for cache, I guess, right? RAM will be keep changing it, but cache we can't do that, I guess.
Yes, no, correct.
Okay.